Okay.
Hi judges, I'm Ke Xingle from Basis International School Nanjing, and I'm gonna introduce a robot which is a Bionic Hexapod robot with magnetic work climbing function. So what is the robot for? High altitude work is hazardous for human to conduct because it takes risk and can easily lead to casualties. So the robot is designed to replace this dangerous human high altitude work. Prior to this, there were similar robots, but few of them is specifically used on the world of magnetics. Therefore, I decided to design a bionic robot to climb on the iron wall by assembling electromagnetic on each 6 legs, which ensure faster speed and more flexible and stable climbing movement. So what did I do in the whole process? I first of all realized the real-world problem that I just mentioned, and I was trying to find a feasible robot solution. And then I designed the overall mechanic structure of this robot. As you can see, this is a bionic hexapod robot with structure based on the hexapod insects in nature. It's a little bit like an ant. And it has a wide hexagonal body shape, and each leg occupying one vertex of the hexagon. And these 2 main boards are designed by me using the AutoCAD and printed in laser. And afterwards, I designed and assembled the structure of the 6 foot. So this robot has a symmetrical leg structure with 3 servos on each leg and 18 in total. So 1, 2, and 3. And then afterwards, I connect all the circuits together. And here is it. It's a little bit complicated. And afterwards, I design and install the fake spherical joint, which is also one of the most important parts in project. So as you can see, this joint is made up by a screw, a nut, 2 gaskets, and 2 short springs to fix the electromagnetic into the tail of the leg. So the electromagnetic utilized need to be attracted toward vertically. However, given the fact that the gate is self-designed, which inevitably contains arrow, and the gravity mass of the robot may influence the movement when it is climbing. So this fake spherical joint is necessary to ensure that the joint connecting these 2 are loose. Like if they have certain angle, it still can be pulled down and be attracted to the wall. And also, like when the leg is moving forward or backwards, this part needs to be rotated at certain angle. So this joint also ensures that point. So then I record the gate movement data with the bus over control. So I can measure the robot's triple gains by hand by dividing each movement into 6 or 7 parts, small parts, and record the distance and angle of each mainline servo and combine them all together. And then I write the servo control and relay program and Arduino codes. So here is where the relays are, and here are the 2 main boards. So the codes include the movement data in the bus over control and also the electromagnetic attraction switch control. So when the 1, 3, and 4 legs are lifted, the codes need to make this 3 electromagnetic lose its attraction to the wall and make the other 3 to gain the extraction. And also I use the Fusion 360 to design the manipulator structure and perform 3D production. And here it is. I haven't plugged in the electricity in the video presentation. So then I complete the final robot assembly and do other experiments to explore further detail of this robot. Then what can the robot do? First of all, as I had mentioned, it can do the manipulator operation. This is a 6-degree freedom manipulator. It has good flexibility and is able to perform relatively simple tasks. Like actually the aim of it is not to do any complicated ones, but to show you that the manipulator can be assembled to the robot and do tasks. And secondly, my robot can perform the ultrasonic detection and alarming. If there is a barrier within a certain distance, the robot will sound an alarm and stop moving forward or backward. And thirdly, it can conduct temperature and humidity measurements. It can accurately measure the humidity of temperature of the environment where the robot is located and record and report it to the controlled computer. Thank you.